Alien radiation, mystery, unexplained high-energy radiation streaming through our galaxy. At first we didn't know where it was from, but we discovered it was gamma radiation coming from somewhere in the center of the Milky Way. The question is, what's making these gamma rays? That's hard to do. It's not like you can rub your hands together and generate gamma rays. When we took a closer look at the gamma rays, we discovered the signature of the most explosive substance in the universe, antimatter. Antimatter is like normal matter, but with opposite charge. That's it. It's matter's evil twin. When evil twin meets good twin, it is not a happy reunion. Antimatter is scary. It's not like you want to have some in your kitchen. This stuff is very explosive if you want to think of it that way. If it touches normal matter, it releases a huge amount of energy. When matter and antimatter combine, they annihilate each other and transform into high-energy radiation, just like the gamma rays seen streaming out of the center of the Milky Way. We see antimatter throughout the galaxy, but strangely, the galactic center seemed to have 40% more antimatter than anywhere else. Right now, in the heart of our galaxy, we actually observe fountains of antimatter that are producing 10 trillion tons of antimatter every second. One of the big questions that we've wondered about for a very long time is, what's the origin of this stuff? Initially, there were several suspects. One possible source of antimatter is the central supermassive black hole, Sagittarius A star. Matter can be swirling around this, and it can have such high energy that it can create antimatter. But the antimatter isn't coming from a single point, it's spread across thousands of light years of space. So Sagittarius A star can't be the source of the gamma ray stream. Another suspect was dark matter. One of the biggest mysteries in the universe right now is dark matter. We know that the majority of mass in the universe is not in the same form that we are. It's not made of atoms, but whatever sort of particle it is, or maybe if these things collide, they can produce antimatter, and that will produce the gamma rays. So it's possible that as we look into the heart of the galaxy and see these extra gamma rays, that's the signal that dark matter is there. But the gamma ray stream we detected is too weak to have been created by dark matter. Then we had a breakthrough. We discovered that a special metal called titanium-44 could be responsible for the gamma ray stream. Titanium-44 is a highly radioactive element. That means that it wants to decay into other types of nuclei. When titanium-44 decays, it gives off antimatter. But to produce the antimatter seen in the galaxy's core, you would need a lot of titanium-44. It could be created in rare energetic events, in the collision of two dead stars, white dwarfs. A white dwarf star is a star that didn't have enough mass when it died to actually become a supernova. It just sort of cools off as a dead little cinder. But what if you have two white dwarfs that are orbiting around each other, and as they come closer and closer and collide, all of a sudden now you have enough mass to actually kick a supernova explosion off? These particular kinds of supernovas are very good at producing titanium-44, so these kinds of supernovas are very good at making antimatter. These supernovas erupt in the core of the galaxy once every 2,000 years. But outside of the core, in the disk of the galaxy where our solar system orbits, these supernovas happen 3 times as often. So the gamma ray observations were wrong. There isn't more antimatter in the heart of the galaxy. It's our region of the galaxy that contains the most antimatter. Question is, are we in danger? If you take an ounce of matter and an ounce of antimatter and collide them, you're generating a megaton of energy, the equivalent of 1,000,000 tons of TNT exploding. So you don't need much antimatter to generate a vast amount of energy. But the thing you have to remember is we live in this wonderful, dramatic environment of a larger universe. It's not dangerous. It's very far away from us, and it's fascinating that all of this antimatter is being produced in our galaxy. So just sit back and enjoy the fireworks. The center of the Milky Way is violent and extreme, but things could get a whole lot worse. Rogue supermassive black holes could be lurking near our galaxy, and they have the power to end life as we know it. Earth has orbited the sun for over 4.5 billion years. Time enough for humankind to evolve into an intelligent and technologically advanced species. But compared to the age of the universe, planet Earth is just a kid. The Earth is over 4.5 billion years old, and we think it's taken this long to create the first technological civilization, us. There are star systems out there much older than we are. The universe is 13.8 billion years old. We tend to think we're hot stuff, right? We're technologically capable. We can build rockets and we can listen to radio waves. But a typical other intelligent advanced civilization would be literally millions of years ahead of us in technology. So, if an alien society has been around longer than us, how much more technologically advanced could they be? One method of measuring just how much is provided by the Kardashev Scale. The Kardashev Scale classifies potential alien civilizations into 3 types, based on the amount of energy that they're able to harness from their local environment. A Type 1 civilization can harness the energy of its home planet. A Type 2 could hypothetically harness the energy of its own solar system. And a Type 3 could harness the energy potentially of an entire galaxy. If you're wondering where we fit on that scale, prepare for some bad news. We're somewhere between a 0 and a 1. We can't use all of Earth's resources, so we're at about a 0.7. An advanced species reaching Kardashev level 2 or even 3 could create highly advanced structures that can harness the power of a star. If you get to be an advanced enough civilization, eventually, if your energy demands are so huge, you might build solar panels that you have enveloped your star. This was first thought of by Freeman Dyson, and so we call these Dyson spheres. If such epic engineering occurs in other star systems or even other galaxies, could we pick up some evidence and then make first contact? The thing about a Dyson sphere is that you've completely blocked all the light coming out from a star except for the infrared, because these panels are absorbing that sunlight and warming up. When you warm up an object, it gives off what's called thermal infrared light. You can scan the skies looking for that signature to see if there are any Dyson spheres out there. 2015, NASA's Wide Field Infrared Survey Explorer scanned 100,000 nearby galaxies to locate advanced Kardashev civilizations by observing infrared light leaking away from Dyson spheres. They detected nothing. No such galaxy was found, so they didn't find any infrared smoking gun. Given our universe is so old, surely other civilizations should have had time to evolve. If so, maybe we've simply missed them. It's entirely possible that civilizations arose, tried to communicate with the galaxy around them, and the problem was they were asking too early for us. They're trying to knock on our door, but our house wasn't built yet. Earth has been around for under 1/3 of the universe's 13.8 billion year lifespan. The human race, just 300,000 years, a relatively tiny window of opportunity to make first contact. We've been looking at the sky for tens of years, something like that. What is the likelihood that at that exact moment someone is going to be beaming a signal toward us? Perhaps the universe prevents intelligent civilizations from surviving for very long, making our chances for first contact even more unlikely. Maybe there is something out there that is filtering us from seeing them. We actually call this the Great Filter. Maybe there is something that says, yeah, you're not getting past here. Rocky planets like ours are ideal for hosting life, but they're fragile. And this fragility means the universe could filter out intelligent life quickly. We've discovered very violent star explosions like gamma-ray bursts. These are powerful enough they may sterilize planets even across an entire galaxy. And even if intelligent species survive natural phenomena, they may still be filtered out by hitting the self-destruct button. As we can tell from our own experience, the moment that we started developing technology, we also developed the means for our own destruction by changing the climate on our planet, by developing weapons of mass destruction. And so it's quite possible that civilizations that are advanced enough are short-lived. And if they're short-lived, that would explain why, at this point in time, there are very few of them that might be around to communicate with us. Finding the relics of an extinct alien civilization could be the ultimate cosmic warning for the human race. If we were to find a civilization out there that may have destroyed themselves by pollution or conflict, it would be almost like staring into a mirror, and it would be a very grim foreshadowing and maybe a lessons learned for us humans here on Earth. We can only hope that some advanced alien species escape the universe's deadly filter. But even if ET still exists out there, the odds are still stacked against first contact. One other way that we've got this alien contact story a bit wrong is just down to the laws of physics. Every day, the physics of the cosmos makes our chances of contact worse because our universe is expanding, and it's expanding fast. February 2018, astrophysicists at the University of Oklahoma find a potential series of rogue planets 3.8 billion light-years away, ranging between the size of our moon and Jupiter. These would be the first alien worlds ever discovered outside our galaxy, and maybe the first of many. Our galaxy alone has trillions of planets. The observable universe has trillions of galaxies. It's estimated about 2 trillion, so trillions of trillions. Come on. But finding exoplanets is no guarantee of finding alien life. And when it comes to contacting extraterrestrials, our efforts have met with silence. Our search for life has come up empty. Do we need to change our tactics? Are we doing something wrong? I think it's going to be very, very hard to find extraterrestrial intelligence the way that we're looking for it. We would have to get really, really lucky, but I don't think we're going to get lucky. I think that if we want to know whether there's life out there in the cosmos, we have to go visit it.